Did you know that, despite Mobile ALOHA's broad features, the entire system of Mobile ALOHA is powered by a consumer-grade laptop? On an exploration into the realms of robots and artificial intelligence, we come across a remarkable discovery called Mobile ALOHA. Let's go further into this intriguing innovation and discover its extraordinary powers, which redefine what's possible in the field of robotics. Mobile ALOHA Abstract. In the field of robotics, imitation learning from human demonstrations has demonstrated amazing performance, notably in tabletop handling tasks. However, the key issue is to apply this talent to activities that require movement and sophisticated coordination, an area where most outcomes have fallen short. Enter Mobile ALOHA, a game-changing solution developed via tireless invention and a thorough knowledge of the difficulties of mobile manipulation. This technology is more than simply another robot. It represents a fundamental change in our approach to automation. At its base, Mobile ALOHA includes a low-cost yet powerful teleoperation technology that captures the essence of human control. By adding a portable base and an advanced teleoperation interface to the existing ALOHA system, Transportable ALOHA overcomes the restrictions of traditional robotics, paving the path for genuinely adaptable and autonomous robots. The magic does not end there. We achieve new levels of performance by carefully collecting data via Mobile ALOHA and employing sophisticated approaches such as supervised behavior cloning and co-training. Consider this. Success rates can rise by up to 90% with just 50 demos for each activity. What does this mean in practical terms? It indicates Mobile ALOHA can now handle complicated mobile manipulation tasks that were previously thought to be beyond its capabilities. Mobile ALOHA exemplifies the height of robotic performance, from sautéing and delivering tiny shrimp to handling large cooking pots and even flawlessly navigating an elevator. From fundamental actions like lane following in mobile robots to complex activities like spreading pizza sauce or inserting a battery, the potential is broad and intriguing. However, the major difficulty is to apply this learning paradigm to activities that require whole-body coordination and bimanual manipulation, which is where Mobile ALOHA excels. Consider the scenario of putting away a heavy pot into a cabinet. This seemingly simple task involves a cascade of actions that demand not just mobility, but also dexterous manipulation and coordination. Mobile ALOHA tackles these challenges head-on, demonstrating its ability to navigate, grasp, and manipulate objects with finesse and efficiency. The path to high-performance bimanual mobile manipulation has been filled with obstacles, ranging from limitations in the hardware to advanced learning methods. Mobile ALOHA addresses these difficulties with a low-cost, whole-body teleoperation system that transforms data collecting and learning methods. By combining teleoperation and deep imitation learning techniques, Mobile ALOHA bridges the gap between human-guided control and autonomous execution, allowing robots to do complicated tasks independently. The main contribution of this study is not only the development of a system for learning difficult mobile bimanual manipulation tasks, but also the discovery of a simple yet effective co-training strategy that dramatically improves data efficiency and learning performance. Imagine a robot that can navigate an office, cook a 3-course dinner, and even do home duties with accuracy and dependability, all thanks to cognitive learning and powerful hardware integration. Capabilities. Let us now go on an exciting adventure through the tasks chosen to demonstrate Mobile ALOHA's outstanding potential. Imagine a world in which robots smoothly integrate into our daily lives, completing tasks with accuracy and delicacy. Are you ready? Let's sink in. First, it can wipe wine. Consider a scenario in which spilled wine threatens to stain your spotless tabletop. Have no fear. Mobile ALOHA goes into operation. The robot base is started inside a 1.5 x 1.5 meters square with a yaw range of up to 30 degrees. It initially moves to the sink and takes up the towel hanging from the faucet. It then rotates around and approaches the kitchen island, picking up a wine glass, randomized in 30 cm x 30 cm, wiping the spilled wine and placing it on the table. Each demo contains 1,300 steps or 26 seconds, Second, it can cook shrimp. Do you like getting lost in some delicious seafood? Mobile Aloha has you covered. The robot and all objects are randomized up to 5 centimeters and 2 centimeters respectively. The right gripper first pours oil into the heated pan, then raw shrimp. The left gripper lifts the pan at an angle, while the right gripper grabs the spatula and flips the shrimp. The robot then rotates around and dumps the shrimp into an empty dish before setting the pan on the table. Each demo contains 3750 steps, or 75 seconds. Third, it can rinse pan. Do you have dirty dishes clogging up your sink? Have no fear. Mobile Aloha steps in to rescue the day. The pan randomized up to 10 centimeters and yaw up to 45 degrees. The left gripper grabs the pan before spinning around to face the faucet. The right gripper opens and closes the faucet, while the left gripper holds the pan to receive water. The left gripper then swirls the water within the pan and spills it out before setting the pan on the rack. Each demonstration contains 1100 steps, or 22 seconds. Fourth, it can use cabinet. Need to store that heavy frying pot? It can also be used in cabinets. The robot can move up to 10 centimeters and the pots up to 5 centimeters. A total of 3 pots are utilized. The robot approaches the cabinet, grasps both handles, and then backs up, pushing both doors open. Next, with both arms, hold the pot's handles and slide forward to position it within the cabinet. The robot then backs up and shuts both cabinet doors. Each demo contains 1500 steps, or 30 seconds. Fifth, it can call elevator. Going out for the day? Mobile Aloha guarantees that you get at your destination effortlessly. The robot begins 50 meters from the elevator and moves randomly throughout the 10-meter wide lobby. The robot navigates around a column to reach the elevator button. The right gripper presses the button, and the robot enters the elevator. Each demo has 2,250 steps, or 45 seconds. Sixth, it can push chairs. Yes, you heard accurately. It can push chairs, and the robot's starting location is randomized up to 10 centimeters. The demonstration dataset includes pushing in the first 3 chairs, and the robot is tested with all 5 chairs. Each demo contains 2,000 steps, or 40 seconds. This exercise demonstrates the mobile manipulator's power and agility in overcoming friction with ease. Seventh, it can high-five. Who says robots cannot be friendly? Mobile Aloha proves otherwise as it navigates around the kitchen island, giving people a friendly high-five. This exercise showcases Mobile Aloha's ability to facilitate human-robot interactions, boosting companionship and collaboration. Is there anything that it cannot do? The answer is no. Hardware. Let's look at the fascinating hardware of Mobile Aloha. Buckle up as we unravel the complexities of its hardware design and capabilities, bringing in a new era of robots in everyday life. Mobile Aloha builds on the success of the Aloha system while expanding beyond tabletop manipulation. The following are the major design elements that make Mobile Aloha a game-changer. Mobile. Consider a robot that travels at a rate equivalent to human walking, around 1.42 meters per second. This mobility enables Mobile Aloha to quickly traverse across numerous locations while smoothly adjusting to different activities. Mobile Aloha's stability during manipulation activities allows it to handle heavy home goods, such as pots and cupboards, with ease. No more concern about toppling over when doing difficult activities. Mobile Aloha is unique in that it can teleoperate all degrees of freedom at the same time. This involves manipulating both arms and the movable base, resulting in a dynamic workspace suitable for a variety of jobs. It has inbuilt power and processing capability, thus it is not limited by cables or external power sources. It is ready to handle duties on its own, increasing its autonomy and utility. The selection of movable bases is crucial to Mobile Aloha. AgileX Tracer AGV, Tracer, checks all the criteria for speed, payload capacity, and cost-effectiveness. Tracer's agility, along with its ability to navigate obstacles and slopes, make it an excellent candidate for Mobile Aloha's mobility requirements. Now, let us discuss teleoperation. Enabling simultaneous control of the base and limbs is a difficult task, but Mobile ALOHA pulls it off gracefully. Users may easily backdrive the wheels by attaching their waist to the movable base, replicating natural human motion. This design not only provides user comfort, but it also improves the robot's response and flexibility. But wait, there's more. Mobile ALOHA isn't just about hardware, it's a complete solution. With a powerful onboard battery, robust compute resources, and integrated cameras for perception, Mobile ALOHA is equipped to handle a myriad of tasks. From housekeeping duties like watering plants and using a vacuum to cooking tasks such as searing chicken thighs and stir-frying, Mobile ALOHA is a versatile assistant in the home. Future directions. Now, let's go on to the next chapter of Mobile ALOHA's progress, where we'll face problems and foresee future growth. Consider Mobile ALOHA, with all its charm and efficiency, standing on the verge of progress. Despite its present brilliance, there are areas for development waiting to be discovered. On the hardware front, they intend to reduce Mobile ALOHA's footprint. Consider this: a robot negotiating confined routes, smoothly gliding through areas where every inch counts. Mobile ALOHA's reduced occupied size of 90 centimeters x 135 centimeters will open up new possibilities for mobility and accessibility. But wait, there's more. The set height of the follower arms adds additional problem. Consider reaching for goods in lower cabinets, stoves, and dishwashers. It's a stretch, literally. To solve this challenge, they want to add additional degrees of flexibility to the arm's elevation. This innovation will allow Mobile ALOHA to approach jobs with increased flexibility and accuracy. Let us now move our emphasis to software. While Mobile ALOHA excels in single-task imitation learning, the possibilities are endless. Consider a robot that not only learns from demonstrations, but also discovers new ways to better itself autonomously. That is the vision we aim for. A Mobile ALOHA that grows, adapts, and innovates. As we end our exploration of Google's new mobile robot, ALOHA, it is clear that this technical marvel has sent shockwaves across the industry. ALOHA exemplifies the never-ending drive of innovation and improvement in robotics.